Okay, so this is going to be the lesson for 4.2 and 4.8. I'm just going to start by noting that we're going to be skipping most of the group work sections in both of these. So I'm just going to make one really big video about 4.2 and 4.8 combined. You'll see when you scroll through that they're together. And there's a lot of pages that are blank, so just keep scrolling through until we get to the next section that we're going to go over. All right, so. And the other thing is that the homework is a hand-in assignment, so just make sure you check Blackboard for it. We are not doing any of the handouts or the application text from the textbook. All right, so 4.2 is all about Pythagorean theorem and distance formula. Pythagorean theorem hopefully sounds familiar to you. Pythagorean theorem is an equation that we can use, or a formula that we can use to find the missing length of the missing side of any right triangle. Okay, so the first problem says the road sign above describes a mountain road with a grade of 8%. So what this means is that this line going up, this is basically your road, and it's going up at a 8% grade. So if you were to think of like an entire circle, 100% of a circle, this is like 8% of the circle, this angle. This is a warning that the road is steep enough to require some extra caution. But what exactly does it mean? The slope of the road is very much like the slope of the line. It's a comparison between how far the road goes up or down for a certain horizontal distance. A grade of 8% means that for any horizontal distance, the change is 8% of that distance. So question 1 says, what's the change in elevation over a 1 mile horizontal stretch for a road with an 8% gain? Well, first thing is, if you notice on this picture, they put 5,280 feet here. That's because this is 1 mile. So the question is asking in 1 mile, so in this distance of 1 mile, which is 5,280 feet, what is this height? And we know that it's going to be 8% of this. So if we did here, 8% is 0.08 times the 5,280 is 422.4 feet. So that's going to be the height that you would have increase in elevation. And then the second question says, why do we write 1 mile as 5,280 feet on the diagram? Well, that's because if we left this as 1 mile, then this would be a decimal, which wouldn't really make any sense because we don't like, if it would be like 0.2 miles, okay? Putting it in feet just makes more sense. All right, so I'm gonna skip the did you get it, and we're gonna come right down here to the next page where it says Pythagorean theorem. So the first thing is, if you look at this diagram, it says A, B, C. And notice that there is this little square in the bottom of this triangle, and that little square means that this is a 90-degree angle. So anytime you have a triangle that has a 90-degree angle, it would either have to have that square or say 90 degrees or tell you it's a right triangle. We can use this theorem, which is a squared plus b squared is equal to c squared. Now, important things to note. So A and B, we call these the legs of the triangle, and the legs are the two sides that connect to form this right angle. So it does not matter which one is A or B. I could have switched A and B. Okay, they are universally switched. They're the exact same thing. It does not matter which one's which. Those two, A squared plus B squared is equal to C squared. Now C, this is what we call the hypotenuse. And the hypotenuse is always the longest side of the triangle. All right. So we're going to apply this in a couple minutes at the next pages. So we're going to skip this technology section. And down here, this is just a review of common square roots. So to get this on your calculator, all of your calculators are going to be different, but there should be a square root button. To get to the square root button, you might have to push the second button or a shift button or something. Make sure you can locate that square root button. If you can't find it, reach out to me and I will help you find it. All right, and basically you say the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. And then there's a bunch of blanks in here. So just make sure, I would try and get these blanks on your own first and then come back and check to make sure that you can do them. So these are exact square roots. And the reason is because if you take these numbers that are on the right, 1, 2, 3, 4, 5, 6, and you square them, so for example, 3 squared is equal to 9. 4 squared is equal to 16. 11 squared is equal to 121. So basically, the square root is the inverse of a square, or the square root is the opposite of a square. okay? And you should be able to get these without a calculator. Okay, now for these next two sections, these are going to be estimates. And to do that, we're going to use this chart over here. So it says the square root of 11. Now, the square root of 11 is not a perfect square. There is no square root of 11 on this chart, which means that it's going to be some number in between. It's going to be some sort of decimal. So if we look here, the square root of 11 is in between the square root of 9 and the square root of 16. So when we say here, we know that the square root of 11 is going to be closer to 9 because 11 is only 2 away from 9, but it's 5 away from 16. So it's going to be some number greater than 3. So see, that's why I said greater than 3. So first thing is I had to choose 3 because 11 is closer to 9, and it's greater than that because it's a bit higher, okay? The next one, square root of 78 is going to be in between square root of 64 and square root of 81. So now you have to ask, which one is it closer to? Is it closer to 64 or is it closer to 81? Well, 78 is closer to 81, so which that's 9, and 78 is less than 81, so the square root of 78 is less than 9. Okay, and then the square root of 99 is less than 10, square root of 124 is greater than 11. I would try those, make sure you can get those on your own. Now, this next section is saying use a calculator to get your final answer. So just put in the calculator square root 11 and you'll get approximately 3.32. It's going to be some other number, but it says here round to the nearest hundredth. So that's why I did 2 decimal places for each of these. So just make sure you check those. Make sure that you understand the rounding portion as well. And if not, let me know. Okay, so this next section is key. So now we're going to use Pythagorean theorem. So first, question 3 is saying, notice that the diagram on page 471 is a right triangle. Use Pythagorean theorem to write an equation involving the length of the missing side of the triangle. So first thing is, let's revisit this triangle. And if you revisit this triangle, if you remember, it looks something like this, right? So let's label A, B, and C. Well, remember, C is always the hypotenuse, which is your longest side. So that means that this is going to be your C. And A and B are the 2 legs. So this is going to be A, and this is going to be B. Okay? Now, we know we were given 2 pieces of information. We know that this was 5,280. That was given to us. And we know that this side, we figured out using the 8% of 5,280 was 422.4. So if you look, okay, I put those numbers, and I actually switched the A and the B diagram from what I did here, but that's okay, it doesn't matter, A and B. So 5,280 squared plus 422.4 squared is equal to C squared. And I left the C as a C because we don't know what it is. Then I took in my calculator 5,280 squared, I got an answer. And then I did 422.4 squared, got an answer, equal to C squared. I added those 2 numbers together, and it gave me this really, really big number. Okay? So, now question 4 is asking us to finish basically doing this problem. And it says, in order to solve the equation, you'll need to undo the square, right? So this is C squared. Well, we don't know what C is. This is telling us C squared is. So to undo the square, I now have to take the square root of both sides. And by taking the square root of C squared, it just leaves us C. And then the square root of this really big number, just put it in your calculator. You should get this. And again, just make sure that you can get that. Okay, question 5 is an application on it. It says, how much farther would you drive on that road than the 1 mile that would appear on a map? So we know 1 mile is 5,280, and we know that they're driving 5,296.87 feet. So just subtract those 2, which means because of the grade, they're traveling an extra 16.87 feet. Okay. So right here, if you notice, I skipped a whole bunch of pages. There is a whole bunch of pages for group section. Please don't do the group section. It's really confusing, and I feel like you're not going to get much out of it, so I just skipped it. Okay, and I have more practice problems on Pythagorean theorem at the very end of 4.2 that we will go over together. So the next section is going to focus on the distance formula. So before you start going here, if you do not understand what I just did on this Pythagorean theorem, please reach out, check up some online videos. Let me know if you have questions so I can help you before you go on, because this is going to basically utilize the Pythagorean theorem to do this. Okay. So moving on, again, we're skipping the group section. We're now on page 477. So this is saying, for question 1, what are the coordinates of the point where the two dotted lines meet to form a right angle? So if you look, okay, it's asking me for this point right here, what are the coordinates? And if you notice, so I'm saying that this distance right here is x2 minus x1, because I know that this is x2 and up here is x1. So if I subtract those, then that will tell me how long this line is. And the same for the y's. This distance is y2 minus y1. We're basically looking at slope here, which means that the coordinate of this point has to be x2, because I'm on the second x, and it has to be y1. So it's x2 comma y1. Okay, so that just answered question 1 and 2. So now it says, using Pythagorean theorem, set up an equation to define the distance of the hypotenuse. Well, we know that this is x2 minus x1, and Pythagorean theorem says a squared plus b squared equals c squared. Well, if you remember, this is a, this is b, and this is c. So I took the things that we have in this diagram and I just plugged them right into Pythagorean theorem. A squared plus b squared equals c squared. And now in order to solve this equation, remember we got to get c by itself. So I just took the square root of both sides. So if I were to take the square root of here and the square root here, I would be left with d equals the square root of this whole entire big thing. And this is our distance formula. So this is a formula that you need to know and have memorized. And it's going to calculate the distance of any line where we have 2 points instead of an actual length. All right, so again, here's the distance formula. We just figured it out. And just make sure you know that formula and have it memorized. If you need to write it down 30 times on a piece of paper to memorize it, please do that. All right. So it says a map of a national park has a grid on it to help reference locations. The camping office is located at the point -510, and a lodge is located at 2, 4. Each square in the grid represents a distance of miles. Okay, so first thing is, so it says find the distance from the camping office to the lodge. So we need to calculate the distance. So first thing is, I have 2 points, -5 and 10, and 2, 4. So remember that each point, so this is an x, a y, an x, a y. So remember, distance formula, x2 minus x1. So I took my 2 x's, I subtracted them. So -5 take away 2 squared, then subtract my y's, 10 take away 4 squared. Now let's simplify. -5 take away 2 is -7 squared, and 10 take away 4 is 6 squared. Okay, now I'm gonna come all the way up here because I ran out of room. Let's simplify. -7 squared. Remember, we're squaring the negative, so it's gonna be positive. -7 times -7 is 49. 6 times 6 is 36, and please note that we're still all underneath the square root. Then I'm gonna say, okay, 49 plus 36 is 84. Sorry, that should be 85, not 84. So the square root of 85 is approximately 9.17. All right, so if you look down here, I added a few extra problems for each example, just so you had some extra practice. And the first 2 are on Pythagorean theorem. So the first one is, I gave you the A and the B, and I'm asking you to find the C. And in this one, I gave you the A, the B is missing, and I'm asking you to find the C. So what I would like you to do is, before you just copy down these examples, I would like for you to try to do these on your own and then check your work to see if you got them. And then I put another example here that says find the distance between the 2 points. And again, try and do it on your own and then check your work to see if you can follow along with what I did. All right, so the next section after this, we're moving into 4.8. Okay, this is in the same set of notes, so I'm going to continue in this video. But I would like to pause, make sure that everybody is good on this. And the homework is a combined homework as well, so there's going to be a lot of information in this one slide. All right. And again, I would pause this video here while you're trying these examples. Okay, so 4.8, this section is all about polynomials. And basically, a polynomial is any expression that has multiple terms that cannot be combined. So for example, x squared plus x plus 2 is a polynomial. All right, so we're going to be doing adding, subtracting, and multiplying of these polynomials. Okay, so first thing is, we are going to be skipping most of the group work of this, but I chose to do this one problem just because I thought that it was a good review from chapter 3. So it says, after studying 2 years worth of sales records, the owner of a popular boutique has found that she can sell $400 per month of a brand of bath beads that was featured on Shark Tank when prices were at $12. When she temporarily lowered the price to $10, she sold $480 per month. Right, so that's all important stuff. So first thing is, she sells 400 jars at $12. So that's this point right here. And then she sold then she lowered the price to $10 and she sold 480. So that's this point right here. And they switched the order that they went, so just make sure that you have that correct. So we're comparing number of jars to the money. Then I calculated the slope because it's asking us to write a linear equation that relates the price of the jars to the number of beads sold, x, and your equation should be in the form P equals mx plus b. P is really just our y. Okay, so let's find the slope. So I found the slope, 480 minus 400 is 80, 10 minus 12 is -2, 80 divided by -2 is -40. So what does that slope mean, right? This means that when she lowers the price, this is 40 jars per $1. Okay, so now I know my slope is -40, and I picked one point, so I chose this point right here, 480, 10, and this is x, y, so I'm using point slope form. Remember, y minus y1 is equal to m times x minus x1. So I plugged in y minus 10 is equal to -40 times x minus 480. And then I'm distributing the -40 into both. So I get -40x plus 19,200. Now to get y by itself, I'm adding 10 to both sides, and it gives us this final equation. Okay? So just noting that we are going to be skipping the next sections of the group work because I don't feel it's very important. I'm just going to point out one thing on page 564 here, that it has the word binomial, and binomial basically means 2. Okay, so 2 terms. Okay, we'll go over this in a little bit. I'm going to go through it together in the next section. Okay, so we're going to come all the way down to page 565, and here are some better examples that we can do. So first thing is, when you're multiplying 2 expressions that have 2 or more terms, you have 2 choices. 1, treat the first expression if it was just a number and distribute it to each term in the second expression. Then use the distributive property to multiply out the remaining parentheses and finally combine all like terms. Or, I think 2 is a little bit easier, multiply every single term in the first set of parentheses by every term in the second set and then combine. So we have this problem here. I'm going to ignore the application part of it. I'm just looking right here, w plus 4 times 2w plus 8. And to multiply this using 2, we have to multiply each part of the first term by each part of the second term. So this W is going to have to multiply by the 2W, and the W is going to have to multiply by the 8. And then this 4 has to multiply by each term too. So 4 is going to be multiplied by 2W, and 4 is going to be multiplied by 8. Now, to make sure that you get all of them, there's this acronym, FOIL, and we can use this to help us. So FOIL stands for first, outer, inner, last. And first means you're going to take the first terms of both, so W and 2W, multiply them together. So W times 2W. Then we have O, outer. What two numbers are on the outer? W and 8. So these are my outers. Now I have my inner. 4 and 2W, they're the inners. Multiply them together. And last, 4 and 8. Okay? So we're taking each term and multiplying it by the term, each term in the second parenthesis. So W times 2W is 2W squared. W times 8 is 8W. 4 times 2W is 8W, and 4 times 8 is 32. And then we're going to combine like terms. So 8W plus 8W makes 16W. And I just want to note that this is not a like term, 2W squared, because it has an exponent of 2. And this right here is your final answer because nothing is like terms. Okay. So here, did you get it? I did it. I used the FOIL method. Do it. Make sure you can get it and check your answer that I have down here. Okay. So moving on. Now this is going to use, we're going to be talking about polynomial addition and subtraction. And the first thing that you need to keep in mind is that when we're doing polynomial addition or subtraction, exponents are not going to change, okay? So when you are adding or subtracting, you do not change the exponents because we're not multiplying. Exponents don't change, okay? They only change if you multiply. And this is just strictly addition right here, so exponents are not changing. Okay, so like terms are going to come together. So 3x squared, 2x squared, I'm doing addition. 3 and 2 made 5. Okay, now the next set. I have plus 3x, a minus 3x. Let's add them together. Positive 3 and negative 3x made 0. And then my last set of like terms, I have a positive 5 and a negative 10, make negative 5. Now we don't need to write this plus 0, so it's just 5x squared minus 5. Okay. Now, next one is on subtraction. Now when you subtract, this minus needs to distribute into all of these because all of these are being subtracted. So when you're minusing, to change it to addition, because addition is easier to work with, I'm going to change the minus to addition, and I'm going to put a negative in front of all of these inside. And I just want to note, so this is going to become negative x squared. Well, what happens when I have a minus a negative 2x? This is going to become a plus right here, right? And this plus negative 7 is going to be a negative 7. Okay, so let's look at like terms. 5x squared. And remember, this is negative x squared. Okay, see how I brought them together right here? 5x squared minus x squared, right? Because I subtracted them all. And then I have plus 3x. And I have this minus negative 2x, right? So see that right here? Plus 3x minus negative 2x. They came together. Those are my like terms. And then I have the plus 2 and the minus 7. Okay, so each piece has to be subtracted. Now I'm going to combine them all together. 5 minus, remember there's a 1 here. 5 minus 1 makes 4x squared. Note I didn't change the exponent. Now I have 3 minus negative 2 makes 5x. And then 2 minus 7 makes negative 5. Okay, so question 3. Question 3 is a little different because now I have a multiplication within this problem. So see this 3 outside this parenthesis? Then we have the 2 outside this parenthesis. We have to take this 3 and distribute it in to each term inside. So I have 3x squared plus 9x, because 3 times 3 is 9, and then 3 times 5 is plus 15. And then we're going to take this 2 and distribute it in to all of these. So the 2 times x squared is 2x squared, 2 times negative 3x is negative 6x, and 2 times negative 10 is negative 20. Okay, now we're doing addition, so I just brought my like terms together. So 3x squared and 2x squared, they came together here. And then I have 9x and negative 6x are my next like terms. They came together right here. And then 15 and negative 20. And then combine the like terms and you get your final answer. Okay? And just note that even though these don't look like final answers, they are final answers because there's nothing left to simplify. All right, question 4. We have to distribute again. Now, the one thing I want you to keep in mind, so this 2 is going to distribute straightforward. I'm just going to do 2 times 3x squared, 2 times 4x, and then 2 times negative 5, and that's going to give you this right here. But here, I'm not just distributing a 3, I'm distributing a negative 3. So negative 3 times 4x squared is negative 12x squared. Negative 3 times negative 5x is 15x. And negative 3 times 1 is negative 3. And then I rearranged and brought my like terms together. So 6x squared minus 12x squared, they came together. 8x plus 15x came here. And then negative 10 and negative 3 came together to give me this final answer. All right, I did the did you get it just so you can try the example. Make sure that this minus, you change the sign of each of these when you're doing it. And try it, check your answer, make sure you got it. Okay. So question 5, this is going to be a review of what we did earlier with FOIL. So again, first, outer, inner, last. So y times y, those are my first, gave me y squared. And then I have outer, y times 7, gave me 7y. Inner, negative 5 times y gave me negative 5y. And last, negative 5 times 7 gave me negative 35. And then you combine together. Okay, first, 2x times 3x is 6x squared. Last, outer, 2x times negative 8 is negative 16x. Inner, 6 times 3x is negative 18x. And last, 6 times negative 8 is negative 48. And then I combine these two together to get negative 34x. All right. So question 6, we have this problem. It says multiply 2x times 3x plus 4. And asking, does it match the description in question 5? Well, I'm going to distribute. 2x times 3x is 6x squared. And 2x times 4 is 8x. That should say plus 8x, not minus 8x. And when you look, it says, does this match the description in question 5? Yes. I'll explain. Well, yes, it does, because you're multiplying each term by each term inside the parentheses. So even though this is only multiplying one term by the thing, we're still following the same procedure. It's just a lot less work. All right, so yes, you're always going to be following the same procedure. In this case, I don't have a binomial to multiply the second one, so we're just distributing one thing, but it's basically the same procedure. FOIL is just something to help you if it's a binomial times a binomial. All right. So we're going to skip through 7 and 8. And now question 9 is a trickier problem. And we're going to multiply a binomial by a trinomial. So this is working you through the steps of what to do. So question A says multiply x by each term of this. So basically we're taking this x and I'm just writing x times this whole second trinomial. And when you distribute it out, you get x cubed plus 3x squared plus 4x. Now the second part is I'm going to take this minus 5 and I'm going to multiply it into the whole entire trinomial. So I'm splitting this and multiplying x first, and then I'm multiplying negative 5. And then that gives us this. And if we take both our answers from A and B, so this is my answer from A, right here, and this is my answer from B, and we add them together, and you combine like terms, then you get this. So this is just a way to simplify if you have a binomial times a trinomial. FOIL is something that can help you to remember how to do binomial times binomial, but it will not work if there's a trinomial. All right, and I decided to skip question number 10. I would like for everybody to try the did you get it, and number 5, I purposely did it out. These are very challenging problems. Check it out and see how you do. All right, so this is the end of 4.2 and 4.8. Please make sure that you are asking for any questions. Chapter 4 only has 2 different days, so it's a very quick unit, and the final's coming up very soon. So the homework is a hand-in assignment. It is posted on Blackboard. Make sure that you do it and let me know if you have any questions.